Okay, so today we're doing solving radical equations for section 2.3, and I'll do a video for the absolute value equations separately. So the first thing you want to do when you're solving radical equations, you're going to isolate the radical form. And we are doing square roots right now, so remember square root is this parent function looks like the hook. Our domain, you remember from last year, it's from 0 to positive infinity. So what you want to do is, when we're looking at these, think of those kind of graphs, because that's what we're actually looking at when we solve these. After you isolate the radical, you're going to square both sides. Because we're doing square roots, we'll square both sides. If we're doing cube roots, you'd cube both sides and so forth. And then the third step would be simplify. And then solve. Now, this last part you have to do. So you have to check for extraneous solutions. Extraneous solution occurs, so let's fill out this box, discuss it. Extraneous solution occurs when you solve an equation algebraically, but when you check your answer into the original equation, very important, when you do original, it doesn't work. You get a false statement, okay? If all of your solutions are extraneous, you have no solution. Okay, so let's use these steps and solve these radicals. Okay, radical equations. So the first one, it tells us to isolate the radical. We have to move the 8 over first. So 1/2 the square root of x equals a negative 3. Okay, and now we need to get rid of the 1/2, so we're going to multiply by the reciprocal, which is 2. You want to do 2 over 1, you can. So these two cancel to 1, and so I have the square root of x equals negative 6. And the next step says to, number 3 says to, excuse me, I'm sorry, this is just step 1. Step 2 says square both sides. And then solve for x. Simplify and solve, and that was rather quickly done. So now the last thing you have to do, though, is check. You have to check your solution. So we need to know, is x, is 36 a good solution? Or is it extraneous? So I'll put 36 up here, plus 8 equals 5. Now you're just taking the left, solving it. They have to equal each other. Don't move anything to one side or the other. Just solve down the left, solve down the right. So this is 1/2 times 6 plus 8 equals 5. So half of 6 is 3. So this 3 plus 8 equals 5. No, that's false. That's not true. 11 cannot equal 5. So this is not a solution then. And so our answer is no solution. We don't have anything left. Now what I want to look at, so thinking the answer key you might see NS, but no solution. But what I'll look at really quick is this certain part right here. When we got to this here, when we had the square root of x equals negative 6. This will never happen. You will never have a square root of whatever's underneath there equal to negative number. It can never happen. So what we have here, so we'll just have cannot, so we'll ask the square root cannot equal a negative number. Okay. You can stop here at this point right here and then just say no solution. I'm fine with that. Okay. If you get to this part and you see this, you can just say no solution. It's the easiest to understand what I just said. Okay. Okay. Let's go on to number 2. Number 2. Again, we're going to have to isolate the radical. So So it gives us 3x minus 8 equals 2. Square both sides, just following our steps. And then we get 3x minus 8 equals 4. Now solve for x. We're in step 3. So I'm going to add 8, add 8. So 3x equals 12. So x equals 4. So let's check our solution. Into the original. 3 times 4 minus 8 plus 1 has to equal 3. Well, this is 12 minus 8. So square root of 4 plus 1, does that equal 3? 2 plus 1 equals 3. So yes, 3 equals 3. It checks. Okay, so therefore this is a solution. Number 3. Okay, so it says isolate the radical, but they're already isolated. There's no extra stuff on the plus or minus whole numbers. We don't have anything in front of the radical signs that's being multiplied to it. So now we can just go to step 2. So we're going to square both sides. Okay, and then we're going to say that this is 2x minus 1, and this is just 5x. Okay, so now let's solve for x. Doesn't matter which side you go. So negative 1 equals a 3x, and if I divide by a 3, I get x equals negative 1/3. So now I got to check. Check back into the original. It's okay that they're radicals with fractions. We're doing fine. Okay, so if I work on this side, I get negative 2/3 minus 1 equals negative 5/3. I want to make sure they're the same on both sides. So if you take negative 2/3 minus 1/3 minus 1, this can change to a 3/3. So change 1 to 3/3. So now if I subtract negative 2 minus 3, I do get a negative 5/3 over here. Now, there's a problem here, though. Doing all this math, I wind up on this side, even I'm checking this negative that's under my radical. Okay, you can't have a negative under the radical, a number like that with what we're doing. So this would actually be a no solution. Even though, okay, even though those two look exactly the same, which is true, it's the negative under the radical when I'm checking. Okay, we don't have eyes with this, so this would be no solution. Okay, and let me write out this. So can't take okay, again, so it doesn't matter. Okay. All right, number 4. Again, we are going to isolate the radical. Again, this 2, there's nothing I can do with that 2, so everything's isolated. So now we'll just square both sides. Remember, this is squaring everything in here. So this is 2 squared, which is 4, and then the square root of x squared is just an x. Take what's underneath here. And then now, solve for x. So follow your rules, exponent rules, and you're squaring on that left there. So you get x equals 1. So now let's check. So what, 2 times the square root of 1, does that equal the square root of 2 times 1 plus 2? So 2, this is just 2. On the side we get 2 plus 2, which is 4, so square root of 4. Sorry, I'm cramming that in there. Is that a little better? So this is just this. This is just the square root of 4, which is 2. So it works. So this is our solution. Number 5. Again, there's nothing we can do to isolate it. That it's already isolated. And again, we always want this bigger one isolated anyways. So now we can just do step 2 and square both sides. Now remember, you're squaring everything. So 1/2 squared, remember that's 1/2 times 1/2, which is just 1/4, times what's under the radical, 4x, equals 2x minus 2. So now what's 1/4 of 4? So again, these cancel to a 1, and so you're just left with x equals 2x minus 2. And so now let's solve for x. X equals 2, negative 2, so x equals a positive 2. So now let's check. So x is 2 now, so in place of this x, I'm going to put a 2. And that has to equal 2 times 2 minus 2. That's under the right. Okay, so now we got to simplify both sides. If you notice, this is already a 4 and it's under the radical, so I can really think about separating those two into the square root of 4 times the square root of 2. You could go ahead and multiply it and get 8, but then you're going to have to do the whole thing again. You'll just jump to this step. If you did that, that's fine, but I was just taking less steps. So the square root of 4 is 2, and I know this is going to go to a 1. So the left is equal to square root of 2, and I'll just go down here and bring this down here. This is equal to 4 minus 2, which is just the square root of 2. So they both check, so this is your solution. Okay, number 6. Now, I have to look at this carefully. This is isolated, and we'd have noticed that this is not under the radical, okay? So we don't have to isolate anything. So now we're just going to square both sides. This is a square, and this is a square, okay? Remember, if you look at this carefully, this is a binomial. It's just as if you had x plus 2 squared. Well, if I see something like that, I know it's written twice, so therefore I'm going to have to FOIL it. Okay, so you're going to have to FOIL this. So we're going to do underneath here, it's just going to be on the left at 3x plus 16. On the right, we're going to FOIL. I'm just going to write it again before I start doing that, so you can see that I should have 2 of these. Careful, the x is under that radical. So now we're just going to FOIL. So if I FOIL, it's going to be the first 2. Write this again. So the square root of 3x times the square root of 3x is just the 3x. Okay. 3x times square root of 3x times 2 is a positive 2 times the square root of 3x. I cannot multiply 2 to the 3 into there. Notice it's like this because this is not a radical. It's just a positive 2. And then here, the inside 2 times the square root 2 times the square root of 3x, and then the last 2 times 2 is 4. Okay, so let's combine like terms. So I have 2 square roots of 3x's and 2 square roots of 3x's, so that means I have 4 square root of 3x. Remember, when you're combining like terms with radicals, you just look at the number in the front. Combine those, and then plus 4. Now, notice I have this radical. If you have a radical left over when you're doing it, you didn't do anything wrong, you did it right, then you know that you have to do the whole thing again. So we start with getting this radical by itself. And if you notice if you combine like terms, if I move everything over to to the left because it's just much easier. This is exactly the same as this, so I can just cancel those. Okay, may not always work that way, but just happens to work that way. If you need to, then you just show. And it's okay if that x falls out, that variable falls out, it doesn't matter. So I have a 16 left on this side. I have 4 times square root of 3x plus a 4, subtract 4 now. Because again, still isolating that, radical. So I get 12 equals 4 times the square root of 3x. It is, again, keep going. Still, okay, so now I'm going to isolate by dividing by 4. So 3 equals the square root of 3x. Now square both sides. Again, I have to follow those steps all over again. And so now I get 9 equals 3x. Solve for x, and we get x equals 3. Oops, I shouldn't circle that yet, but let's just check to make sure that's the solution. Okay, so what we do, we need to go and check it in the original equation. Let's do it down here. So here's my check. 3 times 3 plus 16, the square root of all that, is that going to equal to the square root of 3 times 3 plus 2? So this is 9 plus 16, that's the square root of 25. Does that equal 9? Square root of 9 plus 2. Well, this is 5 on this side, and 3 plus 2 does equal 5. So it checks. So that is our solution. Okay. Last two. Number 7, what we want to do is try to isolate the radical. It is isolated. There's nothing else I can do. They're both big ones, so you don't want to mess with this one right here. We just don't need to. So we're going to square both sides. Okay. This one on this side is not under that radical. So again, this is a binomial. Okay. So you're going to have to FOIL this. Okay. So on this left, I get x minus 1. On the right, I'm going to rewrite this one so that I can see both of them, and then I can FOIL. So this stays the same. X plus 2 times, the square root of x plus 2 times square root of x plus 2 is just the x plus 2. And then the square root of x plus 2 times the 1 for the outside is just an x plus 2. If you want to put a 1 in front of it for right now, you can. And then I do the inside. So I get plus, again, I'll just put the 1 in the front, times the square root of x plus 2. And then the last 2 I multiply is a positive 1. All right, let's combine like terms. So x minus 1 equals this. And I'm going to go ahead and do x plus 3 for this and this. Now, again, the radical is treated like a variable right now, but if I have one of these and I have another one of these, so I actually have 2 square roots of x plus 2. Okay, so let's see what we need to do next. We see that we have a radical, so we're going to have to isolate that radical. So by moving everything to the other side. Okay, so if I look at these x's, they're exactly the same, so I can do this on each side, positive x's. And then I can move the 3 over. So I wind up with negative 4 equals 2 times the square root of x plus 2. Divide by 2. And I get negative 2 equals the square root of x plus 2. I mean, we can go ahead and square both sides, but hopefully if you remember from problem number, I believe it was number 3, where, no, that's, sorry, number 1, excuse me, from example 1 on the other page, we said if we have a radical equal to a negative number, that can't happen, okay? So, so at this point is when you can say no solution and state why. I mean, you should always kind of state why, especially for yourself later on. This is no solution. Now you can go and try and figure this out and solve, but you would still check, and when you checked, you would notice that you would have a no solution answer. One side would not equal the other side, but you can stop here, okay? Again, we can't have a radical equaling a negative number. All right, last one. Number 8, so square root of x minus 16 equals the square root of x minus 4. So again, it's isolated the largest of those two, so we're going to first, since we don't have to do that step, second step is square both sides. So we're going to x minus 16 equals, this is a binomial. So I'm going to already write it x minus 4 times square root of x minus 4. So square root of x times square root of is just x. So that's those two. Then I'm going to do these two. Let me do a different color so you can see. So I did these two first, and I'm going to do these two next. So that's just minus 4 times the square root of x. These two in the middle, minus 4, your inside, you like to say, and then the outside. Negative 4 times a negative 4 is a positive 16. Okay, so if we put those radicals together, I have a negative 4 plus a negative 4 is a negative 8. Square roots of x plus 16. And now we need to isolate the radical. Now, this is exactly the same as this, so I can just cancel those out. So now I'm just going to subtract 16 from both sides. So I get a negative 32 equals negative 8 times the square root of x. So isolate the radical now, because we have to do the whole process again because we're left with the radical underneath. Excuse me, we're left with the radical after we did that first part. Again, I have to isolate the radical again. So now, okay, so I'm going to go up here, so I'm going to have 4 equals square root of x. We're following all those steps. Next step is to square both sides. So we get 16 equals x. So now I got to check. Is that my solution? So I have square root of 16 minus 6. Does that equal the square root of 16 minus 4? So square root of 16 minus 16 is just 0, and square root of 0 is just 0. Here I have square root of 16 is 4 minus 4, and that gives me 0. So yes, it checks. So this is my solution. So please check, circle your solution. And remember, you do have to check. Okay, you do have to check. I have to see the check.